All right. So, let's see how much persons are here first. All right. Good morning, everyone. A quick little joke to start it off. Okay. Where was 2 hiding his power? Anyone can guess?
Hello, sir.
All right. Anyone knows the answer? Where was 2 hiding his power? Good morning. Where was the number 2 hiding his power? Anyone can guess. All right. Let me tell you. He was hiding it index. Get it? Ha! That's fun.
Sir, did you disable the waiting room, sir?
Yes, I disabled it because I don't want to reiterate what I'm saying because I want to just continue moving forward. But if it's yeah, so let's start because there's a good amount of persons here. Right, so today we're gonna learn about specifically index. All right, so we're gonna learn about the square of a number and understand the application. So write this on me. Square of a number.
I'm sorry, forgot to send the link, sir.
Oh, okay. It's in volume 1, right? So we're taking book notes today. So if you have volume 1 math textbook, right, we're on page 92. So we're not using the virtual notebook today. We're using textbooks today.
I don't have.
Right. If you have
using the virtual notebook today, right, sir?
No, we're using textbooks today. So if you have this book, it is gonna be in page. But if you have volume 1, like
what about the book which I have, sir?
Yeah, the gray one, right? You have the gray one, man. So for those who have the red one, let me check which book.
The gray one, sir.
Right, that is page 92, Khalil.
The gray one is page 92.
Right, page 92. Okay. All right, so page 92, we're gonna start by heading up square of a number.
Which book?
Right, which book do you have, Kai?
This one and this one.
Right, so in the gray one is gonna be page 92.
92.
Right. Right, so let's get started. So the square of a number is defined as the number.
Writing, sir.
Right, you're gonna be writing. So
everything from the text, right, sir?
No, just the first line that's in green. We're gonna write that line that's in green. All right. So the square of a number is defined as the number times itself. Have that? Right? So can anyone give me an example of a squared value?
Sir, 7 times 7 is equal 49.
So that would be 7 squared, right? Okay, good. Then now, you're going to write for me, the square of a number can also be thought of as the area of a square. The square of a number can also be thought of as the area of a square. One moment. Right, as the area of a square whose length is equal to that of the base. You're just quickly gonna draw a square for me and put that 7, as Khalil said, is on both sides. All right, and that is that.
Sir, whose length is equal to what?
Whose length is equal to that of the base, so the other side. Right? So just draw quickly a square, and you're gonna say 7 centimeters for the length, and the other side will be 7 as well. So therefore, the area will be 7 times 7, which is 49 centimeters squared. Right? And underline that centimeters squared. We're gonna talk about that quickly. So quickly, just to reiterate, you're gonna draw a square for me. Put 7 centimeters as one length, and then the other side you put 7 centimeters as well. All right, and then you're gonna say the area of this square
I have
is.
a question, sir. So does the square has to be equal to the 7 centimeters? Sir?
No, it could be 5 centimeters, but in your, just make sure that both sides are the same value. So if you chose 5 centimeters, the other side has to be 5 centimeters as well. All right, and you're gonna write the area of that length will be just the squared value. So it'll be, if you chose 5, it'll be 5 squared. If you chose 7, it'll be 7 squared. All right. Then once you're finished with that,
Yes, sir.
are you finished? So underline now the centimeters squared. We're gonna talk about that. All right. If you look on your ruler, you might see millimeters. Some persons have a longer version of a ruler, which is meter rule. Right? Those are what you call measurements. And after you finish drawing a square, we're gonna talk quickly about centimeters and millimeters and all those measurements. Okay, everybody finish? All right. Everybody finish? Okay, that sounds like a yes.
No, sir.
All right, I'll give you one more moment.
Yes, sir. Good at the teaching moment is here, right, sir?
Can you repeat?
So like, I have a question, sir. So we'll be getting an exercise from the textbook.
Yeah, you'll be getting exercise at the end of the class from the textbook, right? Because we're just going through multiple things, and then after the class now we'll give you specifically what your task is. Right? So
I'm going to post it on the board out.
Right, it's gonna be on the portal, but let's just take the notes for now, and then I'll tell you what the task is. All right. So now, after you finish now drawing that square, you're gonna write this for me. What are measurements? Because in the
Sir.
Yeah.
What's the page in the grade book again?
Oh, it's page 92. Page 92. All right. Can anyone tell me what are measurements? Anyone? All right. So in the case of square values, right? In the square now, they told us that we had a length of 7 or 5 centimeters, depending on what you chose. So you're gonna write below your shape that the centimeter measures length. Right for me? Centimeter measures length.
I say, sir, the centimeter measures what?
Length. So it measured the length of the square. Length.
Sir, what do I write after the 49 centimeter square?
Right? You're gonna say now that centimeters in that value measures the length. Right? Does anyone know the different types of measuring for length? Like you have centimeter, millimeter,
Yes,
and meter, right? Right. So write those for me.
Yes, sir.
So you're gonna say other examples of lengths are millimeters, which is mm, and meters, which is just m. Okay. And then we're finished with page 92 after you finish that. Right. Can anyone tell me what time is measured in? Quickly.
Minutes and hours?
Seconds. But
Second.
yeah, so time is an example of another measurement, right? So to reiterate what we said, where you use length to measure distance, where you use meters to measure length, right? Seconds used to measure time. That's basically the correct.
So which page are we on right now, sir?
No, we just finished on page 92, and we're gonna move to now page 280. But I want to make sure everybody's on the same page. Does everyone finish with page 92?
In what? Wait, in the math book?
Right, in the gray math book. This one.
Oh,
Right.
wait, hold on, sir. Can I see it? Can I see that book again?
Sure. All right.
Okay.
Right. So as Khalil was saying a while ago, your task is really going to be doing, if you have the book, right, you can just go to example 29, right, and you see an example done there. And once you understand that, you're going to basically attempt for me the task that is on the other page, which is example.
Question, sir. Example 29 is on which page, sir?
It's on the same 92. So I'm saying that for the task for the topic I would just complete, which is square numbers, you're going to attempt the examples that are posted below the square value on page 92. Understand?
Okay.
Right. So write it for me. Example 29 would be an attempt for you to do. But I'll post it in the portal. But let's continue. So
it's already done, sir, by someone.
Oh, right. All right. Don't pay them, man. I'll post on the portal when I'm finished. Let's go to now page 280. All right. This is a very important one. So the joke that I made a while ago, I promised not to make any more bad jokes. Right? But what I wanted to make you guys understand is that squared values, right, is an application of laws of indices. Anyone remember that?
Square what?
The squared number, right, is an application of something called laws of indices. Anyone remember what laws of indices is?
Yes, sir.
Right. So you're gonna say the squared of a number is an application of laws of indices. All right. If you're on page 280, you'll see it clearly. And we're going to basically write now the 8 types of laws of indices, because we're just summarizing the topic that we've done, which is laws of indices, and I'm showing you examples of this topic. So now we're going to write the 8 parts of laws of indices. So you're going to write for me. There are 8 types of laws of indices. You've learned the first 4. Now in the rest of the class, you're going to learn the remaining 4. Okay, so you could have continued, because remember the first one was multiplication, second one was division, the third one was bracket, and the fourth one was 0 of power. Remember, you guys remember that?
Yes, sir.
So now you're gonna say the 5th laws of indices. Right? Write this on me. A to the negative m. See, let me type it out. So you're gonna say a to the negative m, right? And negative m would be in the power. It's the same thing as 1 divided by a to the m. I went over this quickly in the previous classes. Anyone remember why I said that a to the negative of a value is the same thing as 1 divided by a to that value without the negative sign? Anyone remembers? Let me pick on Zura. You remember? All right, so it's recorded, but I'll put the video there. But remember, I said basically that when you have a to the negative m, you can picture that negative as what? A division symbol. Right? It's telling you that that m is being divided by the power. So you would say, well, basically, you have 1 divided by a to the m. But let me give you an example, basically. Right? So let's go to now, let's see. Let's go to example 59c. Write this for me. Wait, you guys still writing? Let me give you a moment.
Yeah, I finished writing.
All right, great. So let's explain now what a to the negative.
Excuse me, sir, I need to talk to you, sir.
Huh?
Sir, there are only 7 laws of indices on page 280, sir.
My bad, 7. My bad, 7. There's 8, but they're showing you the main 7. There's another one, but they don't show it right here. All right. So in a sense, the 8th one we'll discuss at another time, but it isn't required in your syllabus at this point. Okay, so write this for me. A to the negative m is the same thing as 1 divided by a to the m. It's in the chat. We're going to explain what this means now. So give me a random value. Let's say 2. So you're going to say a to the negative 2. A to the negative 2 is equal to 1 divided by a squared. That's essentially what it's saying. So when you get this negative power, so write this for me. When there is a negative power on a base, when there's a negative power on a base, right, we essentially divide and state the value without the sign, right? So I'm going to give another example, and you're going to tell me what it will be now in a simplified version. Tell me what is a to the negative 7. Nicholas.
A to the negative 7.
Right. Simplified in using the laws of indices, it will be
7. Wait.
Remember, when you have a negative power on a base, you essentially divide the value by 1 and take off the division. Take off the negative sign. So a to the negative 7 would essentially be 1 divided by a to the 7.
Oh, yeah.
Right. Let me give you another example. A to the 15. A to the negative 15.
A to the negative 15.
Yeah. What would that be?
It would be.
Come on. A to the negative 15 would be.
It would be 50. Wait, you said when it's divided, it's.
Right. So it'll be 1 divided by what? 1 divided by 8 to the, yeah.
1 divided by 15.
8 to the 15. Right.
Oh, 8 to the 15.
Right.
So.
Right. Okay.
So 15. What?
Yeah. So it'll be 1 divided by 8 to the 15. Okay. That's the no.
So it's 15.
Yeah. So the value would have been a. It would have been 1 divided by 8 to the 15. But let's go now quickly into the 6th power. So that was the 5th. Let's understand the 6th power. So write this for me. If you're on page 280, you will see now a raised to a fraction. Right? So now we have a value of our a raised to a fraction. Okay, so let's say we have a to the 1 divided by n is now a different value when simplified using the laws of indices. So write this for me. When we have, let me type it out. When we have a power that is a fraction, right? That value can be taken as a part of a root. All right, anybody know what a root is? Because we're going to go through it before we continue. So if I say, give me the square root of 4, anyone know what that would be?
2.
Right. So what did you do with that root? If you got the square root of 4, what was that saying? It's the opposite of...
Multiply 2 times and get 4, sir.
Right. So go on page 96. Let's understand square root. Page 96. So let's pause and let's understand square root. Page 96. Okay. So the square root, let's write this. So right under where you have a to the fraction is equal to a square value, you're gonna say the square root of a number is defined as that number which when multiplied by itself gives the original number. Right. So if we tell you that the square root of a number is when you multiply the number by itself, it gives you the original number. What is the opposite then of squaring a number? It would be called if I tell you that the square root of 4 is 2, but the square of 2 is 4, what is the opposite of squaring a number? That is a very important question. So write it for me. What is the opposite? The opposite. You're gonna answer this for me as a task for your homework. And so, what is the opposite of squaring? Because I'm not gonna tell you the answer. Squaring a number. Right?
Finding the square root of it.
Right. Khalil, you got a mark right there. Good job. So finding the square root of 4 is essentially finding the square of 2. So it's the opposite. Okay? Now let's go back now to our initial page and try to understand how does this tie in now to the fifth or the sixth law of indices. Right? So the sixth law of indices said that we had a fraction a to the 1 over n, right? This will all be in the virtual notebook after class, but I wanted to make sure you're taking your notes first, and then you look at the video that's recorded, and then try to do the task. Because I realize that majority of the class don't really like use the videos that I record, so I want to make sure you're taking your notes first. That's the reason why I switched it this time. So write this for me. We're gonna say a to the 1 divided by n. All right.
A to the 1 divided by n.
Right. So page 280, the sixth law. Are you on that page? Right.
No, sir.
So go to that page from me, page 280, and look at the sixth law of indices. Right. A to the 1 divided by n is telling you that you have the square root of a, right? And that n is doing something on it. So the n is not anymore on that a. It is on the outside of that square root. Right? So previously, the square root of 4 would have given us 2. But if we have a value that's attached to the a as a fraction, right? That value that's in the denominator, which is n, right? It'll now be on the outside of that square root. Everyone understand?
Yes, sir.
Right. But I want to make sure everybody that doesn't have the book now understand. So, David, are you in the book? All right. I'll wait till you reply. But essentially, this is just to simplify a value you are given. You aren't tasked to work out anything. So let me ask Khalil. Khalil, work this out for me. You're going to say 4 to the 1 divided by 3. Put that in now the sixth law of indices. Rewrite that for me and put it now as a value that's can be used as the sixth law of indices. So you would say what?
Sir, should I write it down in my notebook, or sir, should everybody do it?
Yes, everybody's gonna try to do it now. You're gonna tell me now, what do you do when you have 4 raised to a third power? A fraction of third power. Right? We stated that the a now would be under the square root, and whatever the denominator is would have been outside of the square root. Let me see if I can find an example to give you. Okay, hold on. All right. Right? Okay. right, I'm gonna give you one more moment to try it.